Today we will be looking at the Pythagorean theorem and its converse. So many of you have heard the Pythagorean theorem before, but just a review, if triangle ABC is a right triangle with right angle C, then we have that A squared plus B squared equals C squared, where A, B, and C are our side lengths, A and B are our legs, and C is our hypotenuse. So for example here, we have X is our hypotenuse, so we have 6 squared plus 15 squared equals our X squared. So we can find that 261 equals our X squared. Taking the square root of both sides, we can get that the square root of 261 is equal to our X. And we can write the square root of 261 as the square root of 9 times 29. So that equals X. And we can keep rewriting this. Square root of 9 times the square root of 29. So we're just simplifying the radical here. So we get 3 square root of 29 is our X value. So make sure you're simplifying the radicals. Number 2 here, we have that 11 is our hypotenuse. And so we have that X squared plus 9 squared equals 11 squared. Solving, we can get X squared equals our 11 squared minus our 9 squared. So we get X squared equals 40. Taking the square root of both sides, we can get X to be, we can rewrite this as square root of 4 times the square root of 10. So we get X to be 2 square root of 10. So that's solving for a leg and a hypotenuse. In 1 we were solving for the hypotenuse, 2 we were solving for the leg. So common Pythagorean triples. A Pythagorean triple is that all sides are integers. So no fractions, no decimals. All right. So common Pythagorean triples, we have 3, 4, and 5, which also means we have 6, 8, and 10. Just multiplying this row by 2. And then 9, 12, 15, 12, 16, and 20. Filling out the rest of the table here. You should be able to do this on your own. So again, these are our Pythagorean triples. So the converse of the Pythagorean theorem, so we said that if it is a right triangle, then a squared plus b squared equals c squared. Well, we can go the other way as well. If a squared plus b squared equals c squared, then triangle ABC is a right triangle. Also, we have the Pythagorean inequality theorems. If c squared is less than a squared plus b squared, then triangle ABC is an acute triangle. So that's when c is smaller. So if c is bigger, so c squared is greater than a squared plus b squared, then we have triangle ABC is an obtuse triangle. All right, now we are going to determine whether each set of numbers can be the measure of the sides of a triangle, and then if so, we're going to classify it as acute, right, or obtuse. So to begin with, we need to check to see if it's a triangle. We would take 7 plus 14, that gives us 21, which is bigger than 16, so therefore it's a triangle. So 16 is our biggest, which means that it's going to be our hypotenuse. So we want to know 7 squared plus 14 squared, does that equal 16 squared? All right, so we can get 7 squared plus 14 squared to be 245, and we have 16 squared is 256. So 245 is less than 256. So that means that this is an obtuse triangle. All right, B here, checking 9 plus 40 is 49, which is bigger than 41. So it's a triangle. And now we want to check 9 squared plus 40 squared. Since 41 is our biggest, that's our hypotenuse. We want to know, what about that and 41 squared? So we get this to be 1,681, and this side to be 1,681. Those equal each other, so it is a right triangle. And our last one here, we will get 1 plus 7 equals 8, and so that's not bigger than 8. So this is actually not even a triangle. Last problem here, we want to set this up. Here x is our hypotenuse. So we can take 8 squared plus x minus 5 squared has to equal x squared since we have a right angle here. So we get 64 using the box method or foiling. We get plus x squared minus 10x plus 25, and that still equals our x squared. So we can subtract our x squareds from both sides to cancel those out and combine our 64 and our 25. So we're going to get 89 minus 10x equals 0. Adding our 10x to the other side, we get 89 equals positive 10x. So dividing by 10, we get 8.9 equals our x. Good luck!